Alright, this is my video 4 for the Centipede final sprint submission. I'm going to take a look at the factories and the singletons that are in the project, as well as the command pattern for the score, and then the player manager and player data, as well as some of the game manager features around that. So looking at the factories that are in here, if we take a look at the critters inside the strategies folder, there is a factory for the flea, the scorpion, the spider, and the spider score. Inside the factory, you just have a create function and a recycle function. And then only a singleton instance of these factories. And then if we're going inside and looking at the factory, we have this null out up at the top, null out the instance. And then our create flea, we will create an object if there's nothing in the recycled stack to be used. And then we will set the external management to our recycle function to keep Teal from deleting game objects when we call destroy. And then inside our recycle flea function, we can get that flea back from our recycled stack. And then all of the creator or the critter factories will have report various death functions for each one that will send score command of their various command score that they start with. So the flea factory will initialize its pdeath to flea killed, which we can then send to the score manager. And then all the factories will have a terminate that will delete the pointer instance, and then we can run through the stack of recycled items calling delete so that we can clean up the memory. You'll see pretty much all the critter factories are essentially the same. They're all singleton instances with terminate functions used to delete the pointer instance and then run through that stack of objects, making sure to delete all of them up. The spider score is just the 300, 600, 900 value that pops up when the spider dies, which functions very similarly with just a recycled stack of objects that is cleaned up whenever we call delete on the factory. And then inside the centipedes, we have another factory. This was a little different, that it has the create head and body are inside the same factory, as well as the recycled functions that are used to store the deleted objects. There's two different stacks, one for the heads and one for the body, and then there's a pdeath for the head and the body. There's two different command scores. Those are set up inside the constructor whenever we create it, and then we have the create for the head and the recycle for the head, and create for the body and the recycle for the body. And then in the deconstructor, we just loop through both lists, deleting both the heads and the bodies whenever we are closing out. There's a couple other singletons that are in the game. We have as well there's an explosion factory, which is also a singleton, which the explosion factory can spawn both critter explosions and the ship explosion, and then has a recycle stack for each one that we will loop through whenever we call terminate on the singleton. And then the mushroom manager is also a singleton, and if we're looking in here, it has the single pointer instance whenever we first call it, but it's a little different that it's actually a game object as well, which is purely just for the use of alarms when doing field region, which allows for a constant callback with a slight delay to allow for the region to not be an almost instantaneous process. And then looking at player manager, another singleton instance that gets spawned. There's only one instance whenever we initialize. Since my AI player uses FSM, I couldn't get the strategy pattern properly implemented, so at the current state, they are just two different entities that are spawned using the ship factory. That can spawn either ship keyboard or ship AI, and then they have their own recycled stacks that are deleted, as well as the bullet, which also has its own factory, which then is deleted whenever we call the terminate. But the player manager has three player data structs, which just have lives, score, wave, and wave, and then various functions to return or modify those values, either adding a score, getting the score, or various functions for the extra life, which the extra life just keeps track of whether or not you have already obtained that extra life value. Whenever we call next wave on the player data, we'll increase wave if we're not already at the max wave, and then we can also call it deck life, which will decrease the player lives, but if we're already at 0, which will return true, meaning game over. And then upon a game over, we can also call player reset to reset the player to an initialized state. But the player manager just sets all of its static references in the beginning, and the current player defaults to the AI when we start out. And we can return the current player, which will give us the instance or a pointer to each of these player data structs, which we can use to call functions within them. Then we can call such things like player advance to set the next wave for the player, and then call wave manager to start the next wave. And then the game manager can call private player spawn without knowing what current player is, and then the player manager will spawn the appropriate player ship. And then we can also call report death anytime a ship dies, which will call back to this function, and then it will call player death within the game manager. Which player death in the game manager will just clear out the screen and then call field regen, and when that completes, it'll loop back to this, and then we will use various functions within the current player to check whether or not it's game over, and if it is, we can reset and set the current values and then go back to the menu, or otherwise we can start the wave again by spawning a new player and starting the wave. And then inside the actual scenes themselves, so the scenes just have an initialize and a terminate, and they load in all the necessary headers, and then spawn the collision pairs, as well as initializing the game manager with the value indicating what scene it should be. And then anytime the scene is closed, we'll call it terminate and run through all of the singletons and call terminate, which will all delete their pointer instances except for the mushroom manager, which will just call mark for destroy on itself instead of manually deleting.